All right, we're skipping the 101 today. If you're here, you already know what a matrix switcher is. You get the headache of routing a dozen sources to a dozen different screens.
Hmm.
Today, we're looking at a piece of hardware that tries to solve the scalability part of that problem. It's the Kramer VS-3232DN-EM.
Right. And we're not talking about some simple 4x4 box you hide in a rack. This is a modular chassis system. It's built for, the high-stakes places, control rooms, stadiums, anywhere that failure is just not in the vocabulary.
Exactly. And the first thing that jumps out from the spec sheet is that word, modular. This isn't a fixed box. Well, it's basically an empty frame you build yourself.
And that is the absolute key here. I mean, think about it. If you need, say, 17 inputs, you're usually forced to buy a whole 32 by 32 unit.
Wasting a ton of money on ports you'll never use.
Exactly. With this chassis, you build it in chunks of 4. You can start small, like 4x4, and then scale all the way up to 32 by 32 as the place, grows. It just aligns the hardware with the actual business needs.
Which is everything when you're trying to get a budget approved. So let's talk architecture. This Kramer core technology, it sounds like it's made to deal with the nightmare of mixed cabling.
It is. Because in the real world, you never have a clean install. Especially in retrofits, it's just a mess. You might have old copper, some new fiber for a long run.
And twisted pair for all the local stuff.
Right. So Kramer Core lets you literally mix and match those input and output cards in the same box.
Yeah.
The switcher it handles all the conversion internally.
So no more little converter boxes dangling off the back of the rack. That alone cleans things up a lot. But what about signal quality? We're pushing 4K signals here.
That's where their reclocking and equalization tech comes in. And yes, they spell it with a K.
It's branding, but it actually does something important.
It really does. Look, digital signals aren't perfect. They get jittery and degrade over long cable runs.
Right.
This device basically rebuilds the signal. It reclocks the data so it can travel way farther without falling apart.
And speaking of that, the specs list a data rate of 10.2 gigabits per second. Why is that specific number so important?
Well, that's your performance threshold. At 10.2 gigs, you can handle a true 4K signal at 60 Hz with 4.2.0 color. If you dip below that, you start getting compression, you get blur, you get dropped frames.
Which you just can't have in a live sports broadcast or a security feed.
Unacceptable.
Yeah, and speaking of unacceptable, let's talk about the black screen problem. The moment the power hiccups, this unit seems to be built paranoid about power failure.
It has to be. The
Yeah.
specs call out a hot swappable redundant power supply. This is, standard stuff in the server world, but it's critical here. You have 2 power units. If one fails, the other takes over instantly.
And you can pull the dead one out and slap a new one in while the system is still running.
While the game is still on the screen. Yep.
So you have this super robust hardware, but how do you actually control it? I'm seeing a mix of new and old ports on the back.
It spans generations, which is smart.
Okay.
You've got the modern web GUI for anyone who wants to manage it from a browser.
Of course.
But they kept the RS-232 ports.
For all those legacy control systems that just refuse to die.
Exactly. There are bulletproof systems out there from 20 years ago, and this switcher can still talk to them. Plus, it has Maestro automation, which lets you set up these predefined switching scenarios so you can trigger a massive change with just one command.
There's one other feature here that really stood out for any installers listening, the test pattern module. That feels like a huge quality of life improvement.
Oh, it saves hours, just hours of troubleshooting. Normally, if screen is black, you start tracing everything. Is it the source?
Yeah.
The cable?
The display itself.
Right. With this, you just push a test pattern from the switcher itself. If the pattern shows up on screen, you know everything from the switcher onwards is good. The problem's upstream.
It just isolates the variable instantly. So looking at this whole package, it seems like the focus isn't just on passing a video signal. It's on, I guess, minimizing downtime and friction.
It's an industrial-grade solution. That's the takeaway. It's designed to take all this complexity and put it in a box that just stays online.
So before we wrap up, I want to look ahead a bit. We're talking about a solid 4K backbone here, but we're already seeing 8K displays hitting the commercial market. How long until 10.2 gigabits just isn't enough?
That is the big question, isn't it? 8K needs a massive leap in bandwidth. I mean, it really pushes the physical limits of copper.
Yeah.
The next generation of these matrix switchers, they're probably going to need a fundamentally different architecture to handle that kind of data pipe.
Something to think about for the next upgrade cycle. That's our deep dive on the Kramer VS-3232DN-EM. Thanks for listening.